All right, gang, we're going to spend another day talking about arrays. We're going to go away from what the chapter talks about because for part of the lecture, we're going to be talking about lists specifically rather than arrays. And I've talked about the differences between those before, and I will again once we get there. But sticking with the PowerPoint for now. Remaining within array bounds. Every array has a finite size, which is the number of elements in the array. And then behind the scene, there's a number of bytes that data takes up. Looks like we're on lecture S. So if you had an array that looked like this, for whatever purposes, right? That array has a length of 3. If you wanted to find out the length of the array, you could get it, right? Now, strictly speaking, it doesn't have a size of 3, although quite often we call the size and the length of the array synonymous. And if you told, another programmer, okay, so, the size of this array is 10, that would be fine. But what it really is if you recall, we have to have bytes available to us to store this data, and these are integers. So if we said that each integer took up 4 bytes, which is common in a lot of programming languages. I'm not sure that that's true of Python. Python's got better numbers that hold larger numbers than a lot of other programming languages. But anyways, if these were each 4 bytes, then that's 4 plus 4 plus 4, right? So the size of the array in bytes is the number of elements, its length, multiplied by the size in bytes of each element. And I'll say once again that Python does not support arrays. Python supports lists and is using lists as arrays. So in Python, you can do silly things like this. If you wanted to put a number in here and then you wanted to put a string and then you wanted to put, a float and then you wanted to put a Boolean value and then you wanted to put a turtle and then you wanted to put whatever, right? And so obviously the idea of figuring out how many bytes that is versus that bytes that is versus the bytes that is versus, that doesn't really work. But when we're talking about arrays in any programming language that supports true arrays, then this is a true statement. The size of the array in bytes is the number of elements, the length of the array multiplied by the size of each element. We're going to pretend we can't do that. That's just way too alien of an idea. And so arrays are composed of the elements of the same data type. Well, that didn't, but that's because it's a list, right?
Okay, Professor, I have a question. Okay, I somehow didn't comprehend when you're talking about 4 bytes. You're looking at those numbers. How do you know they're 4 bytes?
Well, the silly answer is I made it up.
Oh,
but in
okay,
a great many languages, a non-decimal number is stored in either a 4-byte data type, in which case it can count up to about 2 billion, or an 8-byte data type, in which case it can count up to some number in the trillion, in the quadzillions or something like that, right?
Okay.
A much larger value.
Okay.
So
Okay.
Another example would be if you had an array that looked like this. Each one of these is a single character.
Mm-hmm.
And a character in a great many languages is exactly 1 byte. And a character in Python is 2 bytes so that it can support a larger character set, so that it can support German and French and stuff like that, not just English, all with the same character set. But anyway, so if each character is 2 bytes long, and this is 5, then the size of that array would be 10, right?
Oh, okay. Okay.
So if a character is 2 bytes, and this has a length of 5, the size of memory is 2 times 5 equals 10 bytes.
Okay. So, but we don't really need to figure that into what we're doing now then.
Exactly. Right.
Okay. But I'm glad to know that. Thank you.
Yeah. So like the book says, an array has got data that's all of the same type. Python just, laughs that requirement off. Ha, 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 ha. So, because obviously these are all not, Python's lists are not so limited. But you won't ever see me make up an example where I'm sticking data of different types into a Python list. So elements of the same data type occupy the same number of bytes in memory. The number of bytes in an array is always a multiple of the number of array elements. And you access data using a subscript by containing a value that accesses memory occupied by the array. I think I'm not going to talk further about that. We're just going to keep going with the idea. Well, I guess maybe I will. If, say you have this array of these bytes, well, I'm going to 116, 100. Behind the scenes, let's just say that at byte 1002, we're going to say each one is 4 bytes long. So 1000 and 1003 contains our 1. And byte 1004 to 1007, that's 4 more bytes, contains our 16. And pretend I typed that correctly. Bytes 1008 through 1011 contains our 100, and so on. So in a language that is supporting strict arrays, what an array is it's a reference to that first byte, right? Array first address is 1000. So when you say, give me array subscript 0, what it does is go read byte 1000. If you say, give me array 1, it goes to byte 1004, and array subscript 2 is byte 1008, right? That's how it gets those 3 numbers out. Is byte subscript 0 goes there, and I don't know why I said there. This is a subscript, right? Subscript 1004 and subscript 2. Well, no, I had that right. So the subscript and the byte, a subscript 0 goes to 1000. In this example, a subscript of 1 goes to byte 1004 to read it, and subscript 2 goes to 1008. So that's just a little mathematical formula that it has to figure out, which is something like the memory address of the array, and you would never type this. This all happens behind the scenes. Element is the original address plus subscript times the size of the element. Right, so since we said that each number is 4 bytes, since I made that up, then if you want element 2, then the address would be 1000 because that's the original byte, plus 2 times 4 because 4 is the size, and int. So that would tell the computer that it needs to read byte 1008. So a language that supports true arrays, the arrays are all, the data is all allocated contiguously in memory, one after the other, just like that. And so reading it is just a simple matter of going, okay, I need those bytes, I need those bytes, I need those bytes. All it has to do is update one single thing, and it can step through them. So accessing memory in one of those languages like C++ or Java, ones that do support arrays, is the fastest possible memory address. Yeah, you can get the data the most quickly out of it that way. Now, as I've typed 20 times before, Python uses lists, not arrays. What are lists? Lists are also sequences of data, but they are a data structure that is linked where each element could potentially be in a different place in memory, although we don't really care about that. But you can insert elements into the middle of the list. You can insert elements at the beginning or the end. You can append elements to it. You can delete things from it, right? An array is fixed in length. Once it is allocated, it stays that length. You can't, if it's 10 long, if its length is 10, we can't add an 11th element, right? Can't delete we can't delete an element. Apartment buildings, built in concrete or whatever in a limited space. It's too bad. We put 100 apartments in our apartment complex. That's what we got. But a list can grow and shrink as needed. That's a big difference. They are not fixed in length. They can start off at size 0 and then just start adding things to them. So if you had a list called scores, you could ask the user for some input, and then you could append that to the list. Now, I'm not going to actually write an append statement at this time because we know what happens when we, an input statement, because we know what happens when we add input to our programs, which is each time we run it, we have to type something into to our little test program. So I'm not going to do that, but I'm going to fake it, right? Scores.append 1, scores.append 16, scores.append 100, right? Now this array looks just like that other one, right? Because this one way up here had the values 116, 100. And this one has the values 116, 100. So if we print out the scores list, whoopsie, we'll see that it has those 3 values in it. So there we go. You couldn't do that with a proper array. In a language that supports true arrays, you do something like this. Now, certainly don't memorize this, but in Java, it looks like this. We want an array of integers. You got to give it a name. Oh, come on. We have to put a little marker here that tells it that it's an array. We give it a variable name, and then we ask the computer for some new memory, and we say how many we want in it. I want 3 integers, right? That's how you do it in those languages. You ask the computer for an array of this length, and then that's what you get, right? You have enough memory now to insert 3 numbers. Now, those languages do also support the idea of lists. So anything that we're doing in here is also applicable to those languages. But until today, I've tried to focus on our lists as though they were true textbook arrays, but here we're deviating a little bit. So I do want you to remember that an array is a sequence of data where the values are of the same type. Whoopsie, come back here. Where did my program go? There it is. Oh, went full screen. Stop that. Okay. Forgive that little diversion. All right. So an array is a sequence of values containing elements of the same type. Which is why I'll never again give you an example of something like that. This is more correct, right? Because it's an array of characters, HELLO. This is an array of numbers. So we'll stick with that. We'll stick with that definition. So we can insert data into the beginning of an array. Let's make up another array, which is just our usual silliness about, names or something. We have Bob and we have Carol and we have Doug. How convenient that they're in alphabetical order. Now we get a new kid in town. Alice comes in. We need to put Alice at the beginning of the list. So we're going to do list.insert into position 0, Alice. What the insert command does is it'll put Alice there so that she'll become the new element at position 0, right? Because we know that right now, this is element 0. Whoopsie, whoopsie, whoopsie. That is element 0. That is element 1. And that is element 2. And we would see that if we printed it out by its index, right? If I did one of those 4i in range things and printed out both the index number, I guess I could. That probably takes less time to type it than it does to talk about it. For I in range, the length of the list. So len parentheses l close parentheses, close parentheses. Print I comma and then the element at that subscript, at that index. And then I'm just going to copy and paste that so I can look at what it looks like after it gets inserted. What is there? Why is that blacked out? Several menu options are invisible. All right, as long as the computer doesn't crash, I don't care. Run. All right, and there we go, right? Bob, Carol, and Doug. And then after the insert, Alice became the new element at index 0. And the rest of them had to step back, right? So now Bob is 1 rather than 0, and Carol is 2 rather than 1, and so on. So this adds, well, places a new element at subscript 0. Guess I am going to use the word insert because place might sound like we're replacing it, right? And so then the numbering of all the other ones adjusts to make room for it.
I had a quick question. Do you have to specify the placement of the new element, or is there like a default?
There is, if you're going to insert, you do have to specify the position. If you're going to append, you don't, right? Because append is easy. Append just tells it go to the end of the line. That's easy. But if you're going to insert, you have to tell the computer, you have to tell the language where that's going to be.
Okay, cool. Thanks.
Yeah, sure. So far we've seen two commands. We've seen insert and we've seen append. So now our list getting a little bit longer. Now you don't have to insert at position 0. You could insert in a 1, 2, 3, 4, whatever, right? So Abe, Alice, Bob, Carol, Doug, you know, we could make somebody the new number 2, right? That's 0, 1, and 2. But what if we wanted to insert Barry right here? Well, if Barry was right there, then that would be the new number 2. That's the name of a rock group founded by George Harrison's son. Stuck in my brain, the new number 2. I did not mean to go there. All right, so that's 0 and that's 1. We're going to insert Barry here. And then let's just use our little list again. I mean, our little loop. Right, and there we go. After all that insertion and appending and stuff, Eric went to the end because it was an append. Abe became position 0 because we did insert 0. And Barry became position 2, and the rest of them had to get pushed down. Stuff like that is very, 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 very difficult to accomplish with arrays and very, very easy to do with lists, which is why the inventor of Python went with lists. Much more flexible. To delete an element in an array, what you would have to do, let's just say that I had an array that looked like this. 116, 100, right? If you want to delete that element, what it has to do is it has to create a new array with 1 less in length, right? And then copy all of the elements except the one you don't want into the new array, and then assign that new memory address to the original array variable, and then delete the memory that the original array required, right? 4-step process. And if you were a computer science student in the 70s and the 80s and stuff like that, before these languages with lists and things like that got popular, you learned how to write code that did that, right? So that would be how to remove it, right? So we have this array, we create a new array with 1 less. That was supposed to be the word less, not length, right? So it would allocate a new array. You know, please give me an array that looks like this instead, and it's got only 2 places rather than 3. Then copy all those elements except for the one we don't want. And so if we were trying to delete the first element, our array would look like this. And then it would need to make our original variable point to this new memory, and it would need to release this memory so it wasn't left hanging around cluttering up the program. Way too much trouble. It's so nice just to be able to delete an element or to insert an element. All right, how do we delete an element? I always forget if the command is remove or delete. All right, so there's two ways of removing something from a list. And one I do believe uses just the word delete. So we have this list here, right? It's got, 6 names in it or something like that. You can do this. L.remove Eric. That'll take him out of the list, or you can remove by index. Delete L subscript 0. So Abe's going to be gone too as well, right? So this is a remove by value, and this is a delete by index. So when we print our list out, now Abe, who was at position 0, and Eric, who was at the end of the list, are now going to be gone. So after all this runs, here we go. Abe's gone, Eric's gone. There's a slight bit of a problem, which is that if you try to remove a value that doesn't exist in the array, you're probably going to get an error. Like if we do print our array, we do that. And so L.remove Bob will work, right? Now the array is missing Bob. But if we do L.remove Carol, but we miscapitalize it, then boom, it blows up. So really what we're supposed to do is to put our remove statements after a statement that checks to see if it's even in the list. And that looks more like this. If Carol in L, check to see if this element is in the array. Excuse me, I'm going to start calling them lists now because we're using all the extra expanded powers that lists have. Then you could L.remove Carol. And normally you would probably store that value inside a variable, like who you're going to delete, right? So the value to remove might be Bob. And so you could write if value in L.remove that value. And so Bob's going to be gone. We don't have very many values left in our list at this point. Just 3 names left. Okay, so let's make a little summary of the things that we've learned so far. List.append adds an item to the end of the list. L.insert at position X. Tell you what, I'm going to make this a little bit more complete. So L.append adds item V. L.insert x comma v inserts item v at the specified subscript x. L.remove v removes v from the list, but be careful. We should make sure it exists by doing if v in L. Check to see if item v is in list L. I'm going to tab this over just to make it look pretty. Okay. And then lastly, the delete command. del else subscript x delete item at subscript x from list L. Now let's say that we had kept inserting names and appending names and deleting names, and then our list was no longer in alphabetical order. Right now it is, because when I was doing my inserts, I was kind of careful, right? I was manually looking when I did this. Okay, then if I want, Barry to be in here, I'd have to put, remember when we did that? So there's a way to sort lists. So let's just tack on a few values. Guess we keep getting new kids here. We got Tim. We got Sally. And then we got Brandon. Now we're going to print our list out. Just to make it look a little bit different from all of our other things, because we're getting thing after thing after thing printed. I just put a little describer of what we're actually printing. So now Tim, Sally, and Brandon are also going to be in our list, but they're not in alphabetical order. And it's sometimes awfully nice to have things in alphabetical order. So we're going to sort them. Make sure that that's the exact same, that exact correct syntax. The sort method. Okay, that's correct. So now when I print the list out, the list is going to look like this. And I may not have needed to do the L equals. Yeah, I accidentally destroyed my data by doing that. Sorry. Let me get rid of that. Just L dot sort. And so there we go. After the sorting. All righty. We've got some kind of feedback going. Somebody mute your mic. All right, I'm going to mute everybody. All right. Looks like everybody's muted now. So if you need to talk, you're going to have to unmute yourself, however you do that. Okay. So after the sorting, the list is going to be as advertised, sorted. Right. So Alice, Barry, Brandon, Doug, Sally, and Tim. So that's a new command to add to our list. Along with these 5 things, L dot sort sorts the list. Anything else you want to mention along about that topic? No, that's about enough. So now we're going to talk about slicing. Slicing is using more than one subscript to get a series of data out of a list. What do I mean by that? Right now, our list has, I'm just going to run it and copy and paste what our list has as a comment in it. This is what our list looks like right now. Or I could just make a new one, right? It looks like right now. What if I want only the first 3 values to be put into a new list? L2 is equal to L starting at position 0. And then since I want 3 values, 0 plus 3 is 3. That's the first 3 values. So if I print L2, it's going to say Alice, Barry, and Brandon. Eventually. Or not. Wrong syntax. It's supposed to be a colon there. So what does this mean? The colon means I want everything in the list starting at this subscript and going up to but not including that subscript. And that sounds kind of hinky, but that's just like when you do a range of 1, 10, it actually counts 1 to 9, right? So this number is 1 past where you want it to stop. That sounds complicated, so I just take the length of the list and add it to the first one, right? So if I wanted a list that contained everything from subscript 2 and then 4 items past that, well, that's subscript 2. So L3 is equal to L, starting at subscript 2, and I wanted 4 items. 2 plus 4 is 6. Gets us elements 2, 3, 4, and 5, right? Which is 4 elements. And so that list, L2, is a list now that contains Brandon, Doug, Sally, and Tim. Or excuse me, L3. So how about if I did this? Instead of figuring out in advance what the values are, I'm going to say that I want something starting at position 2, and I want it to go out to that. How many elements are in this list? 5 minus 2 is 3. So starting at subscript 2 and then copying 3 values in, that's what list 4 is going to be. Like that. So this one, we went from 2 to 6. 6 minus 2 is 4, so we got 4 elements in it. This one, we went 2 to 5. So 5 minus 2 is 3 elements in it. Strings work the same way. If I say name equals Darth Vader, and I want to get his last name, well, What's the position of that V? I'm just going to have to count it out by hand. I think it's going to be 6. But anyways, that's position 0. That's subscript 0. 1, 2, 3, 4, 5, 6. Right? So starting at 6. And then it's 5 long. So 6 plus 5 is 11. So if we print out last, it's going to print out Vader. What about the first name? It's also 5 characters long, and it starts at 0, right? So the first name is the name starting at 0. It's 5 characters long. 0 plus 5 is 5. So of course, that is Vader. That is Darth. I suppose, technically speaking, Darth would be a title rather than a name. Whatever. All righty, let's run it. Now, there are some shortcuts. One of them is hardly worth mentioning, which is that if you leave the first number off, it assumes it's starting at position 0. So if I printed our list and then I put a colon there rather than put 0, and then I put a 4 there, that's going to get 0 to 4. Now, that's like a big whoop because what's the difference, right? But anyways, so if you leave the first number off of the slice, it assumes 0. However, you can leave the last number off, and it'll go to the end. And that is very useful, right? Because here I've been specifying exact positions. What if I didn't know how long the list was, right? There was another Sith guy in Star Wars. The Emperor was called Darth Sidious, I believe, and I may have misspelled that. But anyways, I know that if I want his name, I can start at position 6, but let's say that I had no idea how many characters were in his name, and I just wanted to get everything from this to the end. Well, in that case, I would start at the 6th position, but then not even specify, right? Get everything from subscript 6 to the end. So now when we print that, it's going to say that entire string there. Because otherwise, what would we have had to do? If I didn't have the ability to do that, this is what I would have had to do. Something like end is equal to the length of the name minus 1, and then last is equal to name 6 colon end. Or maybe I wouldn't want to split it up into 2 statements. So maybe I would have preferred to do it like this. Last is equal to name, starting at 6, and then going up to the length of the name minus 1. Anyways, you have to do some kind of calculation if you don't have the freedom to just ignore that number and it fills it in for you, right, when it runs. I'd rather not do that, right? Don't know why I'm running it again. Its output's not going to be any different than the last time I ran it. Okay, so slicing, scroll up here to my notes. Slicing is providing 2 subscripts to get a new list that is a subset, right? If you've ever taken classes where you learned about, math and you use the term sets and subsets. And so get a new partial list of just those values. So if you do L2 is equal to Lx comma y, L2 is a list of elements starting at index x and going up to but not including so if it was L2 is equal to L subscript 3 colon 7, start with index with subscript 3 and also get 4, 5, 6, and 7. Nope, no 7, right? And so the length of what is returned is 7 minus 3 equals 4 elements. L2 is equal to L starting at X and then going up with no number at the end. Start at subscript X and go all the way to the end. All righty. Maybe we'll go back to the PowerPoint and start talking about arrays again rather than lists. So Python lists have powers beyond comprehension, right? Have functionalities beyond arrays. So we can do things like this that would be much more difficult with arrays. Appending to the end, inserting into the beginning or the middle, removing an element at a specific position, checking to see if an element is in it. Well, most things have something like that. But if item B is an L, check to see if the item is in the list and then delete that item, or sorting the list, using slicing to get stuff out of it. So in bounds, that's a subscript that's acceptable. Out of bounds is a subscript that's not acceptable. Not acceptable because it's past the end of the array. If your street numbers on your street only go up to 212, then you better not tell somebody to go to house number 213, right? And computers being a little bit weird, they use zero-based indexing rather than one, so the concept's slightly different, but not much, right? So the subscript must be in range. If the array is 10 in length, you can access elements 0 through 9. Because that is 10, right? If you count it out on your fingers, but you named your first finger 0 rather than 1 like real people do, then you get up to 9. If you access out of range, you get an error. So I don't even know how many elements are in our current list of names, but I know that it probably doesn't have 10. So if I say print element 9, that would be the 10th element. Or the element at subscript 9, however you like to think about it. I think that's going to crash because I don't think that we have an array of length 10. I think it's shorter even after because we deleted some stuff and appended. And so it says list index out of range, right? We just tried to access an apartment that doesn't exist in the apartment complex. Right? We tried to access some memory that was past the end of the array. Now, in a lot of languages, using a negative subscript will cause an error. Same thing, right? How can you get past 0? So if this is our list, right? Alice, Barry, Brandon, Doug, Sally, Tim. Copy that again, paste that down here. This is an error, it crashes the program. Crashes because this has a length of 1, 2, 3, 4, 5, 6. The current length of L is 6. So we can only access elements 0 through 5. I'm going to do that business where I put numbers on top of them again, right? 0, 1, 2, 3, 4, 5. Oh, I just had a brain glitch. I thought of something absolutely incredibly important to tell you about that, and it slipped my brain. Oh, yeah. In most languages, you couldn't use -1 because there is no element -1, right? But Python being its own weird little thing, I shouldn't say weird, I should say awesome. If you use a negative subscript, it starts counting at the end. So if I print, let's just print the list out as normal. But then if I print L subscript 0, that's going to be the beginning, right? And if I print L subscript 1, that's the next in line. But if I print L at subscript -1, print the last value, right? What does this one do? This one prints the first value. This one prints the second value. That one prints the last value, and you can keep going even past. Now we're walking up the list in reverse, right? Print the second to last value. So what are we going to see here? When it runs, we're going to print element 0, which is Alice, 1, which is Barry. And then when we say subscript -1, Python says, oh, that's really 5, isn't it? And it prints out Tim. And then when we say -2, it goes back 2 and prints out Sally. And so Doug would be -3, Brandon would be -4, Barry would be -5, Alice would be -6, and -7 would again be past the edge of the list and cause a crash. And there we go, right? Alice and Barry are the values at 0 and 1. Whoops, where'd my output go? Right, 0 and 1. And then -1 is last, Tim, and -2 is Sally, and -3 would have been Doug, and so on. So Python, unlike any other language I've ever used, supports negative subscripts, where -1 is the last element, -2 is the next to last, and so on. And again, why is that useful? Well, otherwise, how do I access the last element? What if I know I want that element, but I don't know its number? So print L subscript -1 is the same as doing print L subscript L in parentheses, L in parentheses, -1 in parentheses, right? Because we got to get the length of the list and then subtract 1 from it, because the length of this list is 6. So when we called LENL, the program would calculate the length of that as being 6 and then subtract 1 from it, and that would be 5, which would be Tim. That sure is nice. I'd much rather type that than to have to type that. It's the same thing, but the prior way is so much better. Just because it's easier to type, right? Much clearer. So -1 just means end of list. -2 is, the next to the end. -3 is the next to the next to the end, and so on. So a program should prevent bound errors. You don't want it to allow to go past the edge of the list, past the end of the list. Some languages will crash when you do that. Python is one of those. Others will go ahead and let the program access that memory, but then it'll be corrupted data, right? Because it'll be whatever bytes are in the computer at that specific point. And eventually that can also lead to a crash, right? Because the data will be garbage. So if here is our array, let's zoom in on that, right? And it's got 3 values. Oh, by the way, I have a question, y'all. Do you see the screen zooming in and out as I do this? No is a perfectly acceptable answer.
No,
Was that a no?
oh yeah, I don't see it zooming in or out right now.
All right, because I have a keystroke that'll blow the Mac screen up and get it larger and larger. But apparently Zoom doesn't translate that. Okay, so anyways, so we have 3 elements here, an element of length 3. And so we have subscript 0, we have subscript 1, we have subscript 2. If we try to get here, that's memory that hasn't been allocated, right? It doesn't belong to our program. And so Python will crash our program if we try to get a hold of it. And here's our memory addresses. If we're saying that this is byte 4000, and each number occupies 4 bytes, then to get to this element, it's 4000 plus subscript 1 times 4, because that's the length of it, and 4000 plus 2 times 4, because that's the length of that one. Thank goodness we don't have to calculate it like that. We just do it like this, with subscripts, plain and simple. So to improve a program, test to make sure that the entered subscript is valid. Like if we listed our values and we asked the user which one they wanted to delete, then we would want to give an error message or use a default value, and that sounds dumb, right? Or to reprompt the user for a new value until it is valid. And so I'm going to about wrap it up here, but let's give an example of that. Let's do print which name should we delete? Enter the number. Enter the index, the subscript number. So the index is going to be the int of the input, right? And yeah, I guess I could have put all of that right inside here instead. Now I'm going to make this look a little bit more complicated than that. I'm going to set this index equal to an invalid value, or at least it's invalid in most places, right? I'm just going to say index equals -1. We're going to pretend that Python can't actually use -1 as a subscript. And the reason we're going to do that is so that we can have a while loop. While the index is less than 0 or index is greater than or equal to the length of len L, then it's a problem. That's an invalid index because it has to be between 0 and 5. So print invalid index. Now, how do they know what the index is, what index values are possible? We should print out our little list, right? With one of those 4 range loops like we did up at the very top. For I in range, parentheses, len, parentheses, L, close parentheses, colon, right? And then let's print out I and then L at subscript I, just to give them a list. You know, we can say that 0 is, you know, Alice and 1 is Bob and whatever. So if they type an invalid index, we need to ask them again. So I'm just going to copy that statement and paste it. And it's going to keep looping because it's a while statement. All righty, now let's delete, right? We can delete that person. Print deleting, end quote, comma, L subscript index, whoever, whatever index they specified. And so del, L subscript index. And then let's print out our list again with this for loop again. Closing parentheses does not match opening parentheses. One, yeah, see, does the same thing. The prior way is so much better. I messed the syntax up. I needed a brace here. So eventually it's going to ask me which index I want to delete, which name, right? 0 through 5. Well, I'm going to do 6. And it crashed because I typed in a non-numeric value. Meh. Run it again. All right, so we're going to delete 6. Nope, that's an invalid index, right? Because we only have 0 through 5. All right, so let's delete Brandon. That's 2. So delete Brandon, and then the del list at that specified position actually did remove Brandon. So now this is what our list looks like. All righty. So let's do some homework. So create a list with 3 colors and 2 more colors at the end using 2.append calls, right? Insert 2 colors, or how about just inserting 1, right? This is going to actually take 2 in 2.appends, right? You can't just do this, right? If I have a list, I can't do append John and, oh, by the way, do that. That doesn't work, right? You have to append 2 times in a row. Just like we were doing up here, right? Way up here, we appended multiple people. I know we did at a certain point. Like that. Just got to do that. So we're going to insert 2 more colors at the end using 2.append calls. Insert a color at the beginning using .insert parentheses L or 0. And then remove the second color using del and then whatever your list is called. 1, right? Just substitute with whatever your array name is. Well, why don't we do that? Create a list with 3 colors. Name the list colors, right? And so we remove the second color using delete colors subscript 1. Sort the list using colors.sort. Remember, you're going to need the parentheses. And then print the list. I don't particularly care how you do it. I don't care if you do it just with a single print statement like we sometimes do, or if you use a loop like that. Or even if we kind of got away from it, but remember the other syntax for printing a list? A for value list, for value in list print value. That still works, right? So this prints a list by its range. This prints it by its values. Either one works just fine. Or if you just feel like it, you can print the list out and let Python worry about how to format it, right? And it'll put those square braces and commas. All three of those work. With a value for loop. And this is print with a range for loop. And this is just dump the list to the screen. All right, so those are the tasks. You're gonna have to research 6 colors that you like, right? That shouldn't be too hard to come up with. 3 colors, append 2 more, insert 1 into the beginning using colors.insert. Remove the second color using del colors subscript 1, and then sort the list using colors.sort and print it out. Does that make sense?
Sounds good.
All righty. If not, contact me, because I'm happy enough to get back into Zoom and look at what you've typed, and you can look at what I've typed and stuff like that. So if you get stuck on a homework assignment, we can do a little, mini session together, and it usually helps people a lot.
Okay.
Let's make a new folder.